All right, let me try it out. Okay, so I guess record is starting. So once again, all right, let's start with like, as I already mentioned, the general idea is that sometimes you want to identify specific code patterns, like maybe for the sake of security, or just you want to enforce like some best practice. And usually, like, not usually, but like in most cases, like you know your code and you know the domain of your work. That means that you know better what practices to enforce in your code, and whether it is a security requirement or some general stuff. And usually, like, just like a silly pictures, but like usually you have this knowledge in like documentation or a wiki in best case scenario. Sometimes it is just in your code, like code is the best reference. Like I worked in a few companies like that. And sometimes it's just in your head. For example, you have an idea that you like want to like keep your code like in this path this way. And the idea is to go from keeping this knowledge in a static form to something that is actively checking and testing your code in a CI environment. So TLDR of this talk is going to be the following. So following code in best practice and writing secure code is very hard. Secure defaults is the future of security. What it means is that instead of looking for vulnerabilities, it is much better to try not to touch dangerous APIs, like not put hard-coded values here, do not put unvalidated user input there, and it is better to create and follow the safe path for developers instead of like trying to find vulnerabilities after that. So next point is that grep is not expressive enough for this purpose. And on the other hand, like SAST static analysis tools, they usually have a bunch of drawbacks, like they're complicated, slow, or expensive, and sometimes everything together in one product. So that is why we need something between grep and static analysis tools that would be fast and easy to use, and hopefully often open source. So, and this is the tool we're going to learn today. It's called Semgrep. So it's like defines all the things that I mentioned above. So let's move on. Semgrep, and you can use it to find security bugs. After you find them, you can enforce specific code patterns to not let this situation happen anymore in your code, and you can get notifications about them, and you can fix and upgrade your code like when you find some. A little bit about myself before we dive deeper. My name is Vasily Yermilov. I work as a security researcher at R2C. We are a small startup based in San Francisco, and our mission is to improve software security and reliability. Also, I'd like to mention that I love JavaScript. I have like a solid developing experience. I worked for about 5 years as a Node.js developer, 24/7. So yeah, I'm happy like to be here with my tribe, JavaScript people. And so the outline for today is that I'll describe the background, the background of main issues with finding bugs, focusing on grep and abstract syntax trees. Also, then we will learn Semgrep. This is like the main part, and also some extra information on how to integrate it into CI/CD, and some more info on rule sets, like the registry of rule sets that are already written. We'll discuss it in the end. Give me a second. So Semgrep is the tool that is open sourced, and it actually has a long history of being open sourced. You can click it. Yep, you can click it, like navigate, download, test it, use it on your machine. You can file bugs, feature requests, like do all the open source stuff with it. Semgrep was first originally called sgrep and was created by Yon at Facebook around 2009, and it was used internally at Facebook for PHP, and had more than 1,000 rules to find the bugs in the PHP. But now it has like a lot more languages supported and a lot of new features added. What's interesting for us, like that you can see there is JavaScript green, like with this green sign, meaning it means like GA, general availability, means like that it's like production ready, if I may say so. And also there is JS6, TS6, TypeScript. They are in beta, but it doesn't mean that it is not working. If you want to like try Semgrep, I encourage you to like use TS6 TypeScript support, because it's almost almost ready for like general availability. I've been working with it like last 2 months, testing like it almost have like no issues. Like you'll definitely find something with it. Also, like take a look at other languages that are supported, because like JS is all like usually used with like for example backend. On the other language, like we have good support for Go, Python, Java. So be aware. All right, so a few things to mention about grep and ASTs. Grep is a great tool to find stuff in the text files, but main like disadvantage that it uses regex. There is a famous XKCD strip. It was quite popular that like if you have regex, you have a lot of problem. Sometimes using regexes on your code turns like to a bigger headache than it was. And the main thing that regexes are created for parsing string. And for example, let me show you, like here's like on the left, there is like, well, let's say there is like, it's like a code samples, for example, like exec function from child process, and imagine a situation where you have like you want to find it in your code base, and you might use regular expression, and it makes sense, but it is useful for rapidly searching some simple patterns, simple text. And like what we see like here is that it gets harder and harder. And when I'll show like it's quite easy to find like the first two. When we have a lot of white space, you should like extend your regex. If there is like new lines and more white space, it gets even harder, and it's almost like impossible to like have like one regex that will cover, for example, that will exclude comments or string literals. So yeah, writing regex is very hard, as I already mentioned, because it mostly for parsing string, and code is actually like not a string. It is a tree. Like you see, like on the left, there is a Python snippet of code, but doesn't really matter in this situation. Like we're, despite the fact that we write code as text in the text files, but compiler look at the code as a tree structure, which is called abstract syntax tree. You can see like on the right, like we have the code broken down into parts, like nodes. And in short, like Semgrep lets you easily search code on this AST level, on this like tree. And Semgrep, instead of like grep, Semgrep knows when something is a function, when something is a string literal, a variable, like, etc. We'll see it in action a little bit later. So a little bit on tree matching. There are many, like actually there are not many, like a lot of tools available to use AST and to find patterns with the AST syntax tree. And well, from those that mentioned here, I can highlight for us like ESLint, TSLint. If I'm not mistaken, like DSLint, even like, because I do a security research in JavaScript modules, I have some stats. Like, if I'm not mistaken, like ESLint is probably like the most downloadable module in the whole like npm. So because it works, but like most users, they just use predefined rules, predefined patterns, And if you want to create your own rule to find something, you have to become an expert in like its syntax in this tool. And it is stackable, of course, but it is not trivial. On the right, there is a screenshot of the rule for ESLint that finding an eval in your code. And it takes like more than 200 lines of code. Well, of course, it's possible to do, but yeah, it's time consuming at least. And also, like if you want to use one more tool, maybe like for another language, and you have to spend time now to learn this tool. So every tool has different syntax. And on top of that, there are also a variety of commercial tools, mostly like for some specific goals, like for security, for example. And like their main disadvantage is that they are like really complicated or slow or expensive, usually altogether. So what's next? Yeah, like where is the Semgrep in this, like between grep and AST parsing? So there is a nice picture. Sorry. It's from an interesting article by Instagram engineering team. There is a link on the bottom, and this graphic shows like the static analysis landscape. The idea is that grep and regexes, they're like on the left. Regex actually is used for linting, and many open source projects still use it. I see it from time to time, and like I should say, like quite successfully. I forgot to put it on the slides, but I should mention that there is a tool called Node.js scan. It is quite popular tool for finding vulnerabilities in Node.js projects. I think I'll provide the link in the end of the talk. It is, and the thing is, it used regexes for finding like vulnerabilities, like common vulnerabilities in Node.js, and but new version is using Semgrep now and in its core. And this is like one more reason to learn more about Semgrep. So as I already mentioned, on the left, there are like regexes. They're easy to use, but like the main idea that they're dumb, or I should say like fragile. You can easily break them or bypass them. While on the right, we have whole program analysis. This like picture shows like Pyre and MyPy. This is like a Python tools for static analysis, and they are powerful but complex. They're not easy like to use and often time consuming. And like in general, whole program analysis, what it does, it analyzes the entire program. So it tracks data flow, traces user input from like all sources, from all the code. And Semgrep is somewhere in the middle. The idea is that it provides an easy interface to match three representations of code, but with like easy to use like syntax of grep. So and also Semgrep operates on files, so it doesn't do like the whole program analysis. It just scans files. And in my like security research experience, this is usually good enough to find bugs in code. And so one of the main ideas is that Semgrep lets you reason about your analysis the way you reason about your code. You can see like a small example. There is like to find eval in the code, you write eval. I'll show you what it means like, just in a second, because we're going to start learning Semgrep. So let's learn. So, but just a few seconds more, like before we start learning, I should show you that like Semgrep, originally this is a command line tool, but we also at R2C, we created a UI so that you can experiment and try rules online. I should open it. So here's like semgrep.dev. You go there, and here is like, it's similar to like regex 101. You can write patterns here. Your code is here, and you can choose language. We need JavaScript. So yeah, and you can test your rules here, write them, results matches should be here on the right. And what we have as our first thing to find. All right, okay. Imagine that we have like an outdated, deprecated API, new buffer. It's proposed to use. Let me switch. Which, yeah, it is proposed to use buffer from nowadays, and we want to find it in our code. So as I already mentioned, like you can reason about analysis like about your code, and the code itself is already a pattern. So let's see, Control C, Control V. So let's run it. And we have a match. Semgrep found a match. This line of code is matched because like this is what we're looking for. But let's say that we don't care about what's we don't care about these numbers. We just want to find all new buffer calls. What we can do is we have like a special operator. It's called ... or ellipsis operator, and it represents a sequence of things. So this could be arguments, parameters, or like entire statements. Basically, with it, we say like, we don't care what's inside of this. And we run. Here we go. We have matches. So it matches all the new buffer, and see that comments are not matched because we don't care about comments. It's just text, and the string literals are not here. And also, like, I know I can do like this, for example. It's not maybe very beautiful, but still valid code. Let me do it like this. And it still works because, as I already mentioned, like Semgrep operates on like AST level, so it understands that this is a new buffer call. Okay, so this one operator itself is very powerful, but we have one more thing. Well, not one more, but like the next thing is called meta variables. So let's say we have, for example, console.log. Yeah, this is just the code I found on GitHub. I just searched for console log. Let's say you want to find console log in your code. You don't want it to be in production. As I already showed you, it's quite easy. You put console log ... So we find every console. Oh, sorry. We find every console log here. Here we go. But the thing is that console log may be not only like log, it can be method, it can be also, I don't remember exactly, error. It can be method called table. Yeah, so you want to match it like also, and you can use meta variable for that. Meta variable is like a catching group in regexes. Sometimes you don't know exactly what you want to match, but you want to like grab a reference to something, like to some expression or identifier or method, some like part of the language. And you can define it with $sign and uppercase. Let's say it's like method, some method from console object, and we run it. So now we have the same match. So we match the error, the table, everything that's like every method from console. Also, like interesting feature, quite useful one that like I have mentioned that like patterns like that I show you, like you can write them like patterns as code, but the like rule itself is a YAML configuration file. So you can combine different rules in one configuration file. So like to narrow down your search, and also like add some features, like for example, messages for notifications and stuff like that. And you can use this meta variable here and output the results. Down here on the right, you see table, match table, error, log, etc. So let's see something more complicated. Where are the slides? Yeah, let's find some security vulnerability. So let's say we have an insecure JWT verify function. It is insecure because it allows non-algorithm, and means that token can be not signed and still verified. So let's find it. As we already know, we just put the code that we want to find, verify. So like we want to, let's find any verify just for the beginning. Now let's be more precise. Like we know that there should be token. We don't know what token exactly, and we actually don't care. So like some token, we put it into meta variable. Some secret, we also don't care. What we care about is this object, and also we don't care was if there is something going to be after that, because actually dot 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 also means like 0 or more. So it can be something or nothing, because like if there is no function, it's actually still a valid verify call. It will return promise, if I'm not mistaken. So anyway, what we're interested here is this object. We want to find algorithms, and we want to find none. But if we look for none like this string literal can be like in the beginning of array, or in the end, like we don't know. We also like don't care actually where it should reside. So we put dot dot dot. So I think it's ready to go, and we find the match. So we found the insecure JWT verify function call, and also, I wanted to mention that because it's an AST level, for example, Semgrep understands that if you have, for example, something here, foobar, it's still gonna understand that you're looking for algorithm property here and still match. Let's move on. Composing patterns, yeah. So on top of that, let me close. So you can, as I already mentioned, like compose patterns together to like make your search more precise. So here, for example, let's find this thing once again, JWT, verify, token, secret, this object, we don't care what's after that. Also, I would like to mention that because like Semgrep understands like the code specifics, it like doesn't mean like if there is a semicolon after that or not. So it will work anyway. It will. I'll show it a little bit later. It will be more evident. So for now, let's focus on this object. So we, as we already did, we want to find, let's say, algorithms with it should find it. Yeah, but the problem is that there is also another issue, the ignore expiration. So it ignores the expiration time of the token, and we also want to find it. So we want to find this or that, and we can extend our rule. We can also add JWT verify ignore expiration true. But this is like, and it works, but it's not very good example because like it matches the one function. Let's like change it, for example, here. So now we can find like both like this vulnerability or this one. And also what I wanted to show you, like, for example, we looking specifically for JWT verify, but for example, in your code, you can for example, have it like, I don't know, for anything like this. For example, you don't know exactly. And of course, you can turn it into a meta variable like this, JWT. JWT. But now, like, we mention every object that has this verify method. And what if we want to be like more precise? What if we want to match only like exactly the JSON Web Token object? So we can narrow down our search by doing this, writing one more pattern, like for example, and is inside. So we want all these two patterns be following this condition of being inside also one more pattern, which will look like this, like JWT require JSON Web Token. For example, we don't care about this, and dot 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 means like everything that from this definition. And what's gonna happen? Like it's going to work. First of all, so we see that this now don't match because it's not a JSON Web Token object. This one is only matched, and once again, like the idea is that it tracks that this requirement is fulfilled, and then this meta variable passed here, and it's matched all together. So this is the way like to narrow down your findings. All this, like if it looks complicated, there is like a documentation for all of the pattern syntax, how to write rules. It's all available. Actually, like after a little bit of practice, it's like very easy to use and understand. So advanced features. What we have here, yeah, okay. As I mentioned in the very beginning, let's say like you have something in your code that is like specific for your code base, something that you know about, something like not the like deprecated APIs and stuff like that, something that is specific only to your code, and you want to like enforce it or find it. And for example, here we have, let's say we have a financial trading application that, and every transaction must be verified before it is made. Like we have make transaction function, and we want to make sure that verified transaction is called before. I have an example code here. So we have a bunch of functions like that have make transaction, and some of them verify the transaction, some of them are not, some of them are, for example, making a transaction and then verify. So some of them like are not correct, and we want to find it. What we need to do is to write a few patterns. So function meta variable like name, for example. We don't care about the name. We also, I believe, don't care about the what's inside. What are the arguments? What we want to find is we want to find the make transaction. So we want to find a function that actually making some transaction with transaction argument. But the thing is, like in this function, there can be some other code. So, and we don't care about it. We just omit that. So now it should find all the functions with make transaction call, like all the functions here. And but the idea is to find those that do not verify this transaction. So now we need to exclude from this matches those that have verify in the right place. Let's do it. And we have and is not. So we want to find everything that suits this, but not do not have verify. Not only it not have verify, but also verify the same transaction. Here we go. So yeah, we should see like everything is fine. Like okay, verify transaction, make transaction. There is no verify. there is the verify I have to make. So this is how you can enforce something, some business logic that you have in your code with these simple patterns. Also, another feature I want to show you is a fix, auto fix. For example, here I took Node.js, just randomly chose this like deprecated API from Node.js. It is it's now dated once it's since 6th version. Nevertheless, let's say there was like this event emitter listener count method, and now it is moved to emitter object listener count event name. So first, let's try to find it in the code. We already know how to do it. Put it here, like instead of emitter, we're gonna have like emitter, and instead of event, like we don't care, event, try to find it. Okay, we found it, like, and now where is the documentation? So in the docs there is like a definition of this fix, auto fix functionality. I'll just open the final example. Sorry. It's going to look like this, like fix in the YAML file configuration, and we we're looking for this pattern, and we want to change it on this pattern. Like in UI, it looks like this. Let's run it. So as it shown here, like we want to change emitter, put it here, and call a listener count with the same event from it. So we found this pattern in the code, and we see the auto fix suggestion here on the right. It's also going to happen in a command line tool. It will like ask you, hey, do you want to apply auto fix or not? So after we apply, we change the code on the pattern that we wrote. So now it's the right thing. Now it's like emitter listener count event. What else? Also, what are we doing here? Okay. Also, like I talked a lot about regexes and how they're like not very effective at some things, but they're actually quite effective at parsing strings. And sometimes you need that. Sometimes you need to like identify, like to distinguish like bad strings from like good ones. And we actually have this functionality inside the Semgrep, so it allows you to like insert regexes into strings. Here's the example of the rule that is looking for like insecure HTTP calls, like it's getting like this link that is not HTTPS, and it is done with this regex. It is should be in the documentation. Give me a second. Regular. Yeah. So the idea is that it uses a Perl compatible regular expression. The syntax is like this, and you put a regex inside, and you match like this method with the Semgrep, and then like enforce also this regex. For example, if we change it here on HTTPS, it's not going to find this one. Yeah, because we changed the regex. So you can also use the regex where it is more powerful. Also, like the idea is that you can use it not only to find bugs or vulnerabilities, it's also quite useful for giving like visibility into your code. For example, you may want to like show like and see all the routes in your application. For example, if it's like monolithic, big application, big web application, and you want to understand like what routes do you actually have. Do they have authorization checks? Like, do they have, for example, JWT cookies, like etc. And also, you want to hook it, for example, into CI and see when the new route is added. etc., etc. It's like a very simple pattern. Yeah, like this is an example of an Express code, Express.js, and like a simple pattern that is looking for method and route, and we put it in the message, and it finds like and gives you like visibility of all the routes, methods, etc. And you can extend this pattern and use it for like it's called like code asset inventory. We use it internally. There is like, it's not a very good slide, but it's like this graph shows like we parsed our internal Flask application and did this like visualization of all the routes, like which of them have their authorization, which them not, like, etc. It helps to like audit code bases. Yeah, it's like better slide, better picture. I don't remember exactly what the colors mean here, but just the main idea. Also, because we talk JavaScript here, I wanted to mention JS6, TS6 support for people who use React, for example. Despite the fact that it's in beta, it actually works pretty well. Oops, something happened. Okay. It lets you also write patterns for how's it called exactly, like the HTML parts of the JS6 syntax. You can easily find, like here there is a dangerous method, dangerously set in HTML. So it works. We actually already created a lot of rules for finding like React best practices. I'll show you it a little bit later. So the main idea that I want to show, like, this is something you can already use, and TypeScript is also in good support. It's getting better every day. You can already look for something specific, like for example, types is like a snippet of some TypeScript, Node.js code. If you like want to use, like, enforce some typing in your code rules, you can do that already. CI/CD integration. So you want not only write these rules locally, but you also want to enforce them in your CI. And it's pretty easy to do with Semgrep. So every time you make a pull request, it will scan your code, show you like the results. There are snippets of how the configuration for this can look like. So here's just a lot of examples in this UI. For example, you wrote a rule, you can share it. So now it's available online by this link, and you can use Semgrep locally. Just provide this link here, and it will parse your code locally with this rule. And also here, there are different like CI environments supported, and just snippets of configuration files. For example, there is a GitHub action with like this that is configured to scan this exactly rule. Of course, you can change it on your rule set and use it like in your CI environment. So this where you can find snippets. But it's actually pretty easy to set up yourself, and it's all written in the documentation. And yeah, here's like, once it's all configured, when you have a match, like you can see it. This is like example from our internal Flask application. Like, not very good slide. It's like small letters, but it found path traversal in this code. Rule sets. Rule sets, or so-called registry, it's an important feature of Semgrep ecosystem, which is like, it's like a set of rules that are already written for you by other people. You can find it here in the explore page. So a bunch of it's like rules that are grouped into like packed by different topics or stacks. What we have here, yeah, we have like hundreds of rules, actually like more than 1,000 now. I already mentioned a Node.js scan tool that is now moved to Semgrep, and use those rules for Node.js scan. We all supported famous ESLint plugin security checks to Semgrep, and have like a bunch of other like rule ideas contributed by Django co-creator, different independent security researchers. So you can use it, it's free. So I wanted to highlight actually a few packs that can be suitable for JavaScript developers. As I already mentioned, there is a React security best practices. You can find it in this link and use, like it covers most widely known practices for React security. Also, we have common JWT mistakes. We did research on, actually, I did this research, the more info here on this link. I took all the JWT dependents from NPM, reviewed the code, found mistakes, and we created like a list of most common ones and turned it into a rule set that you can now use to like avoid these mistakes. Also, we work a lot on not only on finding bugs, but also on like preventing different mistakes and weaknesses. And we have like XSS prevention rules. They work for multiple stacks and what's going on? Not only, what's cool that it's not only for different stacks, it also supports different template engines because like it is a high possibility to introduce XSS weakness in a template. So those like three that I wanted to highlight for JavaScript people. What else? How you can install Semgrep locally? Like if you use Mac, there is like brew install or pip install. Because it's like there is a like it uses Python internally. So when you install it, you just like type semgrep and config and provide the URL or local YAML file with the configuration and check your code for these rules that you provide. For example, like if you want to scan for everything that we have like with JavaScript, the link should look like this. And you can find more of these rule sets in the registry that I already showed. What's coming soon? Well, first of all, a lot of new rules. We work on them constantly, providing new rules, also try to digest new knowledge like from different communities, like Go community, security researchers, etc. Also, we work on cheat sheets. Because like we work, like as I already mentioned, not only on identifying vulnerabilities, but also on not letting them occur in your code. We already have, where's the docs again? We actually released them, some of them like yesterday, if I'm not mistaken. There are like security cheat sheets. Those are for XSS and for different stacks, and they have like this is like the knowledge on how to not let XSS to be introduced in your code, and it's like not only like a cheat sheet, but it's also like in the form of rules that you can use. What else? TypeScript support is getting better every day, as I already mentioned, and VS Code extension. It's in beta now, but like work in progress, so it's like coming soon. So you could run it inside the VS Code and like see results immediately. All right, like wrapping up, what can I also add? Semgrep, lightweight static analysis for many languages. This is how you can install. I already showed you Semgrep. Also, the last thing I wanted to mention, like if you want to give Semgrep a shot, you want to try it, but you have questions, there is a you can find here in the link in the bottom, a very friendly Slack community channel. There are no dumb questions there. You can discuss rules. You can just have some general questions about how it works. We will be glad to answer your questions, and the people from the community also. You can find me here if you want to talk some JS security, for example. So yeah, feel free to do it. Yeah, I guess that's it. If you have some questions.
Sorry, yeah, go for it, Alex.
Yeah, thank you very much for the presentation. Sorry that are not too many people. I wonder if this tool can be weaponized. You see the scenarios, for example, for looking vulnerabilities in the public repos of popular packages. It seems to be quite powerful to find vulnerabilities and relatively cheap to run it on the massive code base. So I wonder if it can be misused. Just your thoughts.
What do you mean misused? Like used in like
Like
malicious?
weaponized, yeah, to find vulnerabilities or like zero-day vulnerabilities in the open source packages.
Well, that's true, but the thing is like the idea here is that it is like open sourced and like it's already there, so everybody can. I think this is what's happening right now in like open source community, because like the security problem is like #1 now. Everybody want like to work on like to make it better. And yeah, like it is possible, like anybody can do it, and it's better for like good guys to be weaponized and find it first. For example, just recently you can find, because I have like now a blog, I found a new methodology for like vulnerability finding. Yeah, just with using Semgrep. You can take a look if you're interested. Yeah, I agree. Yeah. But like the main idea, and like with our rule sets and with our focus, it's more for like not letting weaknesses in the code. So we're gonna like more focus on that, on preventing vulnerabilities rather on finding like some exact vulnerabilities in the code. But this is like, I don't know how to say it, it's like a cutthroat competition now. Everybody can look for the vulnerabilities, yeah, in open source.
Yeah, exactly. Thank you very much.
Yeah, I wanted to ask in the same kind of venue. So what does R2C do? Is this like open sourced as part of their like products, or I mean, I'm trying to understand how R2C uses it, or is it like
I get
what's
the
the
question.
relationship? Yeah, you know what I mean.
Yeah. It's a good question. Yeah, I actually like wanted to put a slide about it. Like the main idea, like because as I already mentioned, like not usually when we talk about SaaS tools or some bug finding tools, they're like closed, and you can like in best case scenario you have like open source tools. But in our scenario, we have like everything is open sourced. The tool itself is open sourced. Rules are open sourced. We wanna like we try to have big community of people working on it. So, and like the money, like let's talk money, like because I'm not the product guy, but the main idea is to like have, and we already like have some steps in it, have a software as a service tool that is going to be like by a subscription. So the Semgrep itself is going to be open source, and the rules are going to be free. Everything's going to be free, but if you want to like have some interesting features and dashboards and like more interesting features for CI, it's gonna be like by subscription.
Okay, thanks. Cheers.
Any other questions, guys, or are we good? Well, yeah, thanks a lot for that. That was good. Thank you very much.
Yep.
If you could just, yes, obviously stop the recording, and then yeah, I think you can just we can just end. That'd be great. But yeah, thanks a lot for your time. And yeah, I'll send out the link on the meetup group as well. But yeah, appreciate your time.
All right, thank you for having me. All right, I can I can make you a host now, yeah, to finish all this stuff. Oh, sorry. So yeah, I stopped the recording. Like, thanks for having me again. Like, you know where to reach out to me if you have questions. So.
Yeah, no, cheers, thank you. That was really good, thanks.
Yeah.
And yeah, we'll be in touch.
Yeah, cool. And we'll provide the slides in the email, yeah, on LinkedIn page.
Yeah, that'd be useful. Yeah, thank you. And yeah, we'll hopefully have the YouTube link like reasonably soon. So I'll send that across to you once we've got it and things.
Cool, awesome. Yeah. So,
Thanks.
yeah,
well, yes.
Bye.
Cheers, guys. Thanks for your time. Have a good evening.
Bye.
Yeah. Bye, guys.
Bye-bye.